Organic molecules do not have simple molecular notations like inorganic molecules, having anion and cations. Example, zinc oxide, KCN. Instead, organic molecules have very complex structures, having long carbon chains, various functional groups, having cyclic and bicyclic compounds. So, Bondline notation is very useful in representing organic compounds in a better, simpler and easier way. So let's check how bondline notation works through an example. So here I am drawing a organic molecule having 9 carbon atoms in main chain and having few subchains. Always remember, valency of carbon is 4. So this is my main chain having 9 carbon atoms. So to draw bondline notation, just remember 2 rules, that if you're having n carbon atoms, you need to draw a zigzag line having n minus 1 sublines. This is rule number 1. And rule number 2 is, all the corners of zigzag line represents carbon. So here we go. Let's take this example. So there are 9 carbon atoms. So we need to draw a zigzag line having 8 sublines. 1, 2, 3, 4, 5, 6, 7, 8. So 8 sublines where each of this corner represents a carbon atom. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now what we check is, we'll name all of these carbon 1, 2, 3, 4. So at 4th carbon, we are having a subchain of CH3. So we'll name it over here also 1, 2, 3 and 4th. So at 4th, we need to draw a subchain. So this corner also represents a carbon atom. So going further, 5, 6, 7, 8 and 9. So on 7th carbon, we are having a subchain of 2 carbon atoms. So this is 5th, 6th. So on 7th carbon, drawing a subchain of 2 carbon atoms, where these 2 corners represent carbon atoms. So you can see drawing this is much more complex than drawing this. So this is the bondline notation of this molecule, and in general all the questions and examples we are going to use bondline notation for organic molecules. To understand bondline notations more, let's solve few questions in which we need to convert the bondline notation form to the normal molecular structure form. So let's solve the first question. So we can see that this is carbon 1, 2, 3, 4, 5. So the main chain is having 5 carbon atoms. 1, 2, 3, 4 and 5. So let's do the numbering. So we can see that on the 3rd carbon, there is a subchain of 1 carbon and there is a pi bond between 3rd and 4th carbon. So drawn the skeleton. Now let's complete the valencies of all the carbon. So this is CH3. The valency of carbon is 4, and since this is sp3 hybridized carbon, it will be surrounded with 4 atoms. So this carbon 1 atom and rest of the valencies will be fulfilled by hydrogen. This carbon, it's already surrounded by 1 atom, 2 atoms, so and it's sp2 hybridized, so it just needs 1 more hydrogen. So this was CH. If we look about this carbon, it's surrounded by 3 carbon and it is sp2 hybridized, so its valency is full and it just needs no more hydrogen. Then if we talk about this carbon, it's surrounded with 1 more carbon and it needs 3 hydrogen to fulfill its valency. Similarly, this carbon needs 3 hydrogen more, here 2 hydrogen. And so this is the correct skeleton molecular formula. So in this question, it's a cyclic chain. So let's name it carbon 1, carbon 2, carbon 3. These are carbon atoms. So 1, 2, 3. So on the third carbon, we are having a subchain, and on first carbon as well, and there is a pi bond between second and third carbon. Okay, so now let's just complete the valencies. This is CH3. This carbon is already surrounded with 3 other carbons and it's sp2 hybridized, so it just needs no more hydrogen. This carbon is surrounded by 2 carbon atoms and it's sp3 hybridized, so it needs 2 more hydrogen, so it's CH2. This needs CH3. If we talk about this carbon, it's already surrounded with 3 carbon atoms and it's sp2 hybridized, so its valency is full. So solving the third question, the main chain is having 4 carbon atoms. So it should be always clear in your mind that the corners of the zigzag line represents carbon atom. You will never face difficulty while solving the question. So these are our 4 carbon atoms, and 1, 2, 3, 4. And on the third carbon, there is a subchain having a functional group OH, and there's a double bond between second and third carbon. Now we just need to cover the valencies. So this carbon CH3, this carbon is already having 3 atoms surrounded and is also having a pi bond, so its valency is full as it is sp2 hybridized carbon. This carbon is also sp2 hybridized and is surrounded with 2 other carbon. It just needs 1 more hydrogen to fulfill its valency. This carbon needs 3 more hydrogen. Okay, so this question is also solved. Coming to the fourth question. So you can start with either chain. I'm selecting this chain as my main chain. You can select any of the chain and I'll name all the corners as my carbon. 1, 2, 3, 4, 5, 6, 7. So in my main chain, there are 7 carbon atoms. Okay, so I'll just name them 1, 2, 3, 4, 5, 6, and 7. So on the third carbon, we are having a subchain, and on the fifth carbon also we are having a subchain of a single carbon, a methyl group. So I'll draw on the third carbon we are having a subchain, and on a fifth carbon we are having a subchain. Okay, so there is a double bond between third and fourth carbon, so I'll draw a double bond over here. There is a triple bond between first and second carbon and sixth and seventh carbon as well, so I'll draw the triple bond. Okay, so it's just time to complete the valencies. So I'm starting with the first carbon. It's sp hybridized carbon and it is surrounded with 1 carbon atom and is having 2 double bonds, so it just needs 1 more hydrogen to complete its valencies. So this is gonna be CH. This carbon is already surrounded with 2 atoms and it's sp hybridized, so it needs no more carbon atoms. This carbon is sp2 hybridized and is surrounded with 3 carbon atoms, so its valency is full, no more hydrogens needed. This carbon is sp2 hybridized and is surrounded with 2 other carbons. It needs 1 more hydrogen to complete its valencies. This carbon is surrounded with 3 carbon atoms and is sp3 hybridized, so it needs 1 hydrogen to complete its valency. And if I talk about the sixth carbon, it's sp hybridized and already surrounded with these 2 carbon atoms and requires no more hydrogen. And if I talk about the seventh carbon, it's sp hybridized, surrounded with 1 atom. It just needs 1 more hydrogen. So question 4 is also solved. So these are the solutions for all of these questions.